Today we're talking about symmetry in two-dimensional figures. So there are two different types of symmetry. The first type is line symmetry, or you could think of it as reflection symmetry. It's when your figure can be mapped onto itself by a reflection in a line. So mapping something onto itself means it's kind of like if you could fold it in half and the two halves would line up perfectly. So it's basically like it would lie, like it would match up perfectly on top of itself. So it's like, I think of it as like you can fold it in half and the two halves would line up. So a heart has a line of symmetry right here. So if you think about if you folded that heart in half, the left side of the heart would map on top of the right side of the heart. It does not have a line of symmetry like this. That's not one of its line of symmetries because the top of the heart would not map completely onto the bottom half. It wouldn't match up. So this heart has one line of symmetry. This is a regular pentagon. It has a line of symmetry right, I totally missed it, right through the vertex. So that's one of its lines of symmetry. This half maps completely onto the other half. But if it's a regular polygon, it actually has as many lines of symmetry as it does vertices. So this pentagon has 1, 2, I kind of messed it up. 2, 3, 4, 5 lines of symmetry. So I kind of messed it up, but this pentagon has 5 lines of symmetry. So any regular polygon has the same number of lines of symmetry as it does vertices, as it does sides. So a hexagon has 6 lines of symmetry. A triangle has 3 lines of symmetry if they're regular. Okay, the second type of symmetry is rotational symmetry. So rotational symmetry is when you rotate your figure somewhere between 0 and 360 degrees about the center of the figure, and it's going to map onto itself. So if you think about this cross plus sign type figure, I traced it in pink so you can sort of notice like I can rotate that cross, that plus sign, and it's a little bit off, but like it maps onto itself. I can rotate it and it maps onto itself. Again, this is sort of janky. So order is the number of times that a figure maps onto itself as it rotates from 0 to 360 degrees. It's basically like if you think about how many times it would take for your figure to get back to where it started. So if you sort of think of, like, kind of watch this top line, I rotate it once, and now it's right here on the right side. That's 1 rotation. 2, now it's this bottom line. 3, now it's this left line. 4, now I'm back where I started. Now it's back at the top. So the order for this plus sign is 4. That's the number of rotations it takes for it to get back to where it started. Magnitude is the angle of rotations, like how many degrees you're rotating with each of those rotations. It's the smallest angle through which a figure can be rotated so that it maps onto itself. So magnitude is 360 degrees divided by the order. So all the way around, one full rotation would be 360 degrees. And if I'm making 4 individual rotations to get back to where I started, this magnitude would be 90, 360 divided by 4. So this plus sign shape has an order of 4, and it has a magnitude of 360 divided by 4, which is 90 degrees. This pentagon, you kind of started with this top vertex, you rotate it once, it's here, rotate it twice, it's here, rotate it a third time, it's here, a fourth time, it's here, a fifth time, you're back to where you started. The order is 5, and the magnitude is 360 divided by 5, which is 72.